real quickly, we'll go through, this is the reason we picked metal finishing, just a little bit of background here is, Region 6 has a pre-treatment consortium in all their states and their municipalities, and they have an annual conference, and for the last few years they've asked me to come in and talk, and every year they give me a different category to talk about, and metal finishing is the first one, and then since everybody has metal finishers, it seems the most popular one that people want to talk about. But this will be the abridged version. If you have questions later, I'm happy to answer. But facilities that are subject to 433 with the metal finishing regs have to be doing one of these 6 core operations. If they're not doing one of these 6 core operations, then they're not covered by the regulation. They don't have to be discharging from one of these 6 core operations. They can be discharging only from an ancillary process, but they have to have one of these 6 core operations in place. And here's my quick, here's my Tennessee example of how this works. Electroplating is basically, I'm taking your paper. Electroplating is basically you've got an anode material that sets in a bath, and it's using electrodeposition to remove a portion of the surface from the anode to the workpiece, which is the cathode. So it basically is taking a layer off of that piece and putting its coating onto the workpiece. Is essentially what it's doing using electrodeposition. That's as technical as it gets. Okay, who can tell me what the next one was, which is what electroplating?
Yeah.
It's it's essentially it's chemical deposition of a surface from of a coating onto the workpiece, so there's no electricity involved. Anodizing is basically altering the surface of the metal. You're putting a coating of oxide on the surface, and typically aluminum is the material that's most commonly anodized. And coating actually includes 4 processes: chromating, phosphating, coloring, and passivation. And all 4 of these are basically conversion coating to the surface of a workpiece. It's pretty self-explanatory. Chromating, you're using some sort of chrome bath to alter the surface of the metal. Phosphatizing, you're using a phosphoric bath. Primarily, phosphoric baths are used to prepare metal for another process, painting. Phosphoric baths will help the painting adhere to the metal better. And a lot of times we'll have industries that will challenge their classification. And because they're saying, we're just cleaning, we're not doing anything, we're just cleaning before we paint. Well, if you do away with that little cleaning, weak acid cleaning bath that you have, where you're paint adhere to your product, where your customers like your product as well as they do? No. Well, then there's a reason for that. It's because you're altering the surface of the metal so that paint can adhere to it, and that's why you're a 433 facility. Passivation uses nitric acid to alter the surface of the metal for further work, and also strengthens. Not just metal. We actually, and not many people know this, but over the years we've dealt with a number of facilities. The work surface doesn't have to be metal. It can be glass, any kind of etching on glass or anything like that. That's going to be considered metal finishing also. We just, Ishii went to one yesterday that they were etching on glass, and that is considered subject to 433. There's a couple in Tennessee that do that as well. And then, chemical etching and milling is exactly what it sounds like. It's removing parts of the metal using a chemical etch, or putting a design surface on a part using a chemical etch. And the printed circuit board manufacturers, if you've never been to them, they're especially putting plating putting a, what's the term? It will take an electric circuit. What's the term? The conduit. You're basically putting a metal. Oh well, yeah. It's basically putting a conductive material on a non-conductive material, creating a pattern, a circuit pattern, basically, is what you're doing. And it could be on glass. It could be on some other surface as well. It's non-conductive. But printed circuit board manufacturers, and there's a slide here later talks about that. That are if they do it primarily as an outsource for other facilities, and they're exempt from it. And then, in addition to the 6 core operations, there's 40 ancillary operations that the reg covers. I provided them all. I'll mention a few of them. But the cleaning is the one that creates the biggest issues for us. Where, like I said, industries are constantly saying we're only cleaning these parts. We don't do anything else with them. And so we have to go in and evaluate. Are they just using detergent? Sometimes they're just removing the oils and the dirt from it so that they can do another process. But if that process includes painting, typically, then they're going to be covered. Barrel finishing or tumbling. This is for a small part tumbler. Then you see some tumblers are shaped kind of like that shaker that I showed you at the industrial laundry. They're more cylindrical and open. And they're basically using ceramic media of different sizes and shapes depending on the parts. Then it's just a deburring operation and smoothing. And what you get out of that is a wash water that has detergent sometimes, and then also have a rinse water after that, and some typical wastewater that you see from that operation. Impact deformation. If you've ever been in some of the larger machine shops, they have hydraulic presses that it's just basically reshaping material using a strong impact force. I think blacksmith is a very simple explanation for what impact deformation is. And then pressure deformation is using, it's the same concept. You're reshaping the material using a much slower process and more pressure. And again, you may have quench tanks or rinse tanks or something like that, where you're going to generate wastewater as a result of that. And then I mentioned, or I highlighted the brazing and soldering just because you have quench waters that come with those. And the only difference in those two operations is the temperature at which they're done. You're basically putting a capillary layer of material between two pieces to hold them together. And brazing is done at above 800 degrees Fahrenheit, and soldering is below 800 degrees Fahrenheit. Electrochemical machining is the exact opposite of electroplating, where you're taking a layer of metal off of the workpiece and putting it onto the anode, so you're removing a layer off of the material. This is my ode to Peyton Manning and the Denver Broncos. It's centering. If you watch the first play of the Super Bowl. But centering is actually, and we have a facility near me that does this. They take metal powders, and using high pressure, they create mechanical parts out of these metal powders. Metal powder working is an extremely dangerous process. So be aware that if you go and inspect one, the facility that's about 10 miles from my house has had 3 explosions in the last 2 years because of it. Hot dip coating is basically that's a hot dip bath in molten zinc. So galvanizing is when you see something galvanized, it's a hot dip coating process. That's what that is. And again, these are just other processes that are associated with typical metal finishing works that if they have one of those core operations would be covered. Painting in particular, solvent degreasing, they're going to generate wastewaters. Obviously, you're going to have oils, you're going to have heavy metals. And then if you've ever been into a electropainting booth where they use statically charged parts and the paint will adhere to it, and I think I have another picture as well. No, maybe that's it. It's basically a powder coating concept where they charge the piece, and then you got to obviously charge the paint. It's a powder that adheres to it. It's basically just dust if you went up and did it, but until it goes into an oven, and that seals it onto the part. And sometimes they have a wash after that, sometimes they don't. Smaller ones may not be regulated, may not have any type of wastewater generating from it. But also note that some testing operations can be covered under that. And again, I've already mentioned this. The metal finishing, we talked about this earlier, but it is one of those categories where they have an option to get out of the TTO or the total toxic organics monitoring if you want to develop a toxic organic management plan. But, and also if they have cyanide treatment, they can get the ultimate minimal cyanide limit. We recommend cities, even if they do a TOMP and are opting out of their certification or their TTO monitoring, we recommend the city sample for the local limit value as well. Some of the facilities are the existing job shop electroplaters were not transferred over to metal finishing, so there's only ones that are still covered under 413. There's no such thing as a new source electroplater, by the way. If anybody permits an industry as a new source electroplater, that's a clear indication that they don't know what they're doing. So there's no such thing. But job shops basically own 50% or less of the material that they're processing. And I already mentioned the extension for the printing press. I think also I mentioned during the categorical regs, and this is one of the examples, look 433, if you've got an industry that does electroplating or polishing or chromating or passivation as a subpart of one of these operations, 433 does not apply to them because they're covered under these components. Now, what you end up with, and maybe educate your cities on this. If I can learn to operate this thing. Yeah, apparently. Some of these categories, while they wouldn't be subject to 433, they don't necessarily have all the pollutants that are regulated under this category that 433 regulates. So they may not have all the metals that are regulated by 433. So in that situation, you would want the city to make sure they're at least sampling for those metals to compare with local limit, just as sort of a peace of mind type scenario. Some of the, again, some of the things that you're typically going to see in wastewater from these types of operations, obviously heavy metals, you're going to see oil and grease and then do wipe down parts. Obviously, you're going to see solvents. You may, what are they doing with spent filters? The video, if you were in here when I showed the video of the illegal discharger, and I don't remember the numbers exactly, I've got them somewhere, but they were disposing of filters from their treatment system. They were so high in metals that they were beyond the hazardous waste numbers by about 100-fold. The peanut crew had to come in the hazmat so we could get them out of the dumpster so they could do tests on them. And there was green stuff dripping out of the vents and it got into their air ducts. It was not good. But there's a number of sources of potential waste. Another thing we do when we go out to inspections, make sure that they've got proper labels on their hazardous waste. And we check the dates, make sure they're disposing of those properly. But again, spent acids, periodically, even machine shops that have these CNC machines, they use these constantly recycled coolants or lubricants. Periodically, they have to dispose of that. So, figuring out, are they disposing of that off-site? Do they have procedures in place? Sometimes you can't get that down the sewer, unfortunately. So, just being aware of that at these facilities. This is another test of just sort of how in tune industries are with their operation. A lot of times if they have a belt filter press or sludge press of some sort, they're dewatering their sludge, they're developing a cake that they're shipping off the solid waste, and I'll ask them what % solid that cake is, and I'll get 99% solid. Limestone's not that, and you can squeeze it in your hands and stuff. So if they're telling you that, they clearly have no idea what they're dealing with or what they're doing, and that just kind of scares you. So, there's an education process again that goes on. But that's a good test of whether or not they know what they're doing and how confident you can be in their ability to run that treatment facility. Typical treatment technologies for metal finishing, chemical precipitation is primarily what you see everywhere you go. But prior to that, you will see some membrane filtration occasionally. But prior to getting to the chemical precipitation, if they've got chrome bearing waste streams, then they need to do chrome production, and that's basically they're dropping the pH to about 3, and that converts the soluble hexavalent chrome to the more insoluble trivalent chrome. So then it'll settle out when you raise. They use sodium metabisulfite to drop that pH down, and then once they get that conversion, they'll raise the pH back up, and it mixes back in with their other metal waste streams, and they'll do that. They raise the pH using sodium hydroxide to get the metals to fall out. And copper and chrome will typically fall out 8.5, maybe as high as 9. They'll drop out. Nickel and cadmium won't drop out until it gets about 10, 10.5. And then the other two metals, which I'm drawing a blank over, which I thought left out, nickel and zinc, I guess. 9 to 9.5, typically when they'll fall out. And if they have a cyanide bearing waste stream, then they have to do cyanide destruct. So typically all they do is they raise the pH and they add bleach to it and let it set for about 30 minutes, and it'll convert the cyanide to cyanate. And then they'll let that set for a while, and then they'll add bleach again, and it'll convert that to CO2, nitrogen, and so that's how they do that. And then you may also see metal finishing facilities that have DAF units to separate the oils before they discharge.
Hey Chuck, would you talk about where cyanide sampling should be sampled?
Well, I tell you this: if you have cyanide in your waste stream, you've got gold platers from your, all gold platers will have cyanide in their waste stream. But you need to, like if you're talking about collecting the sample, they need to sample at the end of that cyanide-bearing waste stream prior to it mixing with everything else. And that's how they, and I don't know if you heard me say this earlier, that's how they caught that one guy that they traced, they were starting, in addition to the nickels and the nickel and copper that caused them across the wastewater plant when they were collecting samples, they started seeing cyanide above detection also, and they know that's typically associated with gold platers, and only had 2 gold platers in town, so they traced it back to that industry.
Or gold recovery from.
Yeah,
Like,
yeah, and that's how they found the guy, basically. So pre-treatment CSI. Okay, so just a couple of quick examples of how these things apply. You've got the answers in front of you if you want to close your book. You got a facility that started in '72. Their average discharge is 9,000 gallons a day. And in '94, they added an anodizing line. And so these 2 lines combined, and then they're treated, discharged through one common outfall. Their new flow rate's 14,000 gallons per day. So would they be an SIU that's non-categorical, 413 over 10,000 and 433, or 413 under 10,000 and a 433? 413 is electroplating, 433 is mouth finishing. Anyone? You get a free burger to fry out of it.
B.
B. B is the incorrect. Well, hey, just because you spoke up, I'll give you a
Nice.
Who was it? Ready, catch? I'm not a back row, so let me be
Yeah,
careful.
I want you to know you.
Oh, I did.
Yeah.
So is it because once they added the new line, the old process got reclassified?
Well, it was under 9,000 gallons, and it was prior to 1972, so it was prior to the metal finishing regs being promulgated, so that electroplating still applies, because it's a separate process. If we go back, can I go back?
Yes.
Yeah. They added an anodizing line after the fact. Their wastewater combines, but their processes aren't together. It's 2 completely separate different processes. So they have, their one line is subject to 413 under 9,000 gallons, under 10,000 gallons, and the one's subject to 433.
So you have to sample some lines separately.
Or
Combined waste stream formula.
Or everything becomes more.
or you do the combined waste stream formula
Oh,
and
okay.
get an alternative categorical limit. That's a whole other training.
That's like a whole day and a half.
Yeah, we
I
ought
guess
to.
if you sample the lines separately.
We need to do one on permitting and combined waste stream formula and that's and enforcement, really. And then and there you go. And this again, that explains to you why you've got that there with you, so it's something that you have as a tool for you down the road. And then here's another one, golf club manufacturer, for the guy in the back corner who plays golf with Jack Daniels, apparently. He didn't, that's what Aaron knows.
We heard you
I didn't
this
know Jack
morning.
Daniels swung a golf club. So you got a golf club manufacturer, 2 stage vans, no discharge from the plating operation of the wrench tanks, because they use counter current wrenches, which is a very common practice. Now, the only discharge from the plating operation is 350 gallons a day. So, are they a non-significant industrial user, meaning you're not worried about them? Are they non-significant categorical industrial user? Are they electroplating new source less than 10,000 gallons? Are they metal finishing new source?
Yeah,
D.
It is D. Why is it D?
It's over 100 gallons, so it's not in the non-significant categories, and since it's post-1992, they can't get 413 anymore.
That is correct. There's no such thing as a new source electric